Okay, I want to start off this video with, I guess it's just a basic concept. Okay, so what I've done here is I've drawn, I guess it's a map of some sorts. So let's pretend that you've gone to a music concert, something like Big Day Out. Well, I'm not sure that exists anymore, but Soundwave, something like that, some sort of group music festival. And there's 5 different bands you want to go see. So these are some bands that I've just chosen sort of at random. So there's Walk the Moon, Green Day, Muse, RHCP's Red Hot Chili Peppers, and the last one is the Rubens, which I think I spelt incorrectly, but that's okay. And the lines in between the dots that represent each band show the paths that you can take to go from one band to the other. Now, what we're going to do is we're going to show this map in a matrix form. Okay, so generally speaking, what you want to do is when you're looking at a problem like this and it wants you to lay out all the ways you can travel between things, the matrix that you're going to have is going to be a square matrix. So if you're unsure what that means, maybe you should go back to the intro video to matrices, but it's going to be a square matrix, and each band will be represented as a row and a column. Okay, so I'm going to have W for Walk the Moon. Bad W, but that's okay. M for Muse. G for Green Day. R for Red Hot Chili Peppers. And T for the Rubens. I'm going to represent them this way too. W, M, G, R, T. All right, and we're going to draw a matrix that's going to roughly sort of fill this space. Okay. So now the way that you read this sort of matrix is you read that if you were at this place and wanted to go to one of these, could you take a path there or not? And if you could take a path, you'd write a 1. So 1 is could go, could walk. If you can't walk between those two, as in there's no direct path, you would say can't walk. All right. So that's how we're going to look at this. So we'll start off with Walk the Moon. So if I was at Walk the Moon, I wanted to see Walk the Moon, which is themselves, there's actually no direct path that I could take. Right, the 2 paths out of there, I would end up at other bands. So that's a 0 here. Could I go from Walk the Moon to Muse? No, I can't. Walk the Moon to Green Day? No, I can't. But I can go to the Rubens and the Red Hot Chili Peppers. So I'm going to put 1s in those columns here. Okay. Next, I'm going to look at Muse. So from Muse to Walk the Moon, can't get there. I can't go from Muse to itself. Muse to Green Day, there is a path. No. Muse to Chili Peppers, and Muse to the Rubens is there. Now Green Day. Green Day can't go to Walk the Moon. They can go to Muse. They can't go to themselves. They can't go to Red Hot. Sorry, I'm looking at the wrong one. They can go to Red Hot Chili Peppers, but they can't go to the Rubens. Okay. Next, Red Hot Chili Peppers can go to Walk the Moon. That's good. Can't go to Muse. Can go to Green Day. Can't go to themselves, but they can go to the Rubens. And then the last one, from the Rubens, they can go to Walk the Moon. Can't go to Muse. Can't go to Green Day. Can go to the Chili Peppers, and they can't go to themselves. All right. So we end up with a matrix that looks something like this. And because this is a graph that it doesn't have directions, so for example, it's not saying that you can only go from Walk the Moon to Chili Peppers and not back the other way. Because it's not directional, we actually have a line of symmetry, which is a good way to check if you've actually got it right. So if you go down this line here, diagonally, you should see that these ones are all matching up to a mirror image. Must have stuffed this one up from the Rubens. Like from the Rubens to Muse. So there you go. See, I made a mistake and I just found it by using this method. All right. So that matches up to there. Zeros, ones. Cool. The rest of it looks good. That's a good way to check to see if you've got it right. This is called an adjacency matrix. And basically it shows how can you communicate between things or how can you travel between things. Now, this is called direct communication, which means that you can only travel, in this case, in one step. All right. Later on, we'll be looking at two-step communications, which is how many times can, let's say, if you wanted to travel from Walk the Moon to Green Day, by 2 steps you go to Chili Peppers to Green Day, or you could go. Well, that's probably it, right? So they're two-step communications. So it's probably a bad example. What about Chili Peppers to Muse is a good example, right? So by two-step communication, you could go from Chili Peppers to Green Day to Muse, or from Chili Peppers to Rubens to Muse. And the way that you actually find that is just by squaring this value, which you can do in your CAS. Yeah, I guess it's the idea behind the adjacency matrix and sort of how that works. Hopefully you found this video somewhat rewarding and interesting. Thank you for listening.